All right. Well, welcome everyone. It is my pleasure to be here today. You can think of this kind of as a ballast water 101 presentation. I'm going to be speaking a little bit about the ins and outs of ballast water, and I'll get into it. So in July 2006, the motor vessel Cougar A sailed out of Hiroshima and carried a cargo of over 4,700 Mazda vehicles. Before sailing into U.S. waters, law requires that the ship's ballast water be purged of seawater taken in from waters outside of the U.S. In order to reduce the risk of introduction of non-native species. So when performing this ballast water operation, water from the starboard ballast tanks was drained without being refilled simultaneously with fresh seawater. Almost instantly, the unbalanced vessel keeled over on its port side due to this unbalanced weight. The crew were lucky and they sustained minor injuries and were rescued by the U.S. Coast Guard and Alaska Air National Guard, and the vessel was eventually righted. In a recent publication that examined trends in the detection of aquatic non-native species in the 50-year timeframe between 1965 and 2015, scientists found that an average of 43 new non-native species per year were detected. That amounts to one new detection every 8.4 days. Stowaways in ballast water were the most important single pathway for introduction of non-native species globally during this time frame. My name is Kelsey Prihoda, and I share science with the transportation industry in order to help them apply scientific data to their work. And I have been lucky enough to spend much of my career studying ballast water management options to determine which options are ecologically beneficial and operationally feasible. So today I want to focus on 3 points. The first being that ballast is critical to maintaining the stability of a vessel and the safety of the crew on board. Second, using water as ballast has had unforeseen and unintended consequences globally. And third, science-based ballast water management will reduce the risk of introduction and spread of aquatic non-native species from ballast water. So first I'm going to touch on what ballast water is and why it's critical to maintenance of the stability of a vessel and the safety of the crew. Ballast is really simply defined as a heavy substance, such as rocks or water, that is placed in such a way to improve the stability and control of a vessel. Every vessel has a carrying capacity or dead weight. If a vessel is not fully laden, it has not met its full carrying capacity, it is buoyant. And buoyancy can cause dangerous conditions like lack of propeller immersion, heeling, or listing to one side or the other. Trim, meaning the front or the back of the vessel is more submerged than the opposite. And stresses on the vessel hull can occur as well as instability. So unbalanced vessels are dangerous. To avoid these dangerous conditions, vessels use ballast during cargo operations in port, during conditions when they have no cargo or light cargo, when there is unequal distribution of weight in the vessel cargo hold, so non-homogeneous cargo, during certain weather and sea conditions, approaching shallow waters, and also during consumption of fuel and diesel oil during a voyage. Simply put, vessels fundamentally rely on ballast water for safe operation as a function of their design and construction. Solid ballast, meaning sand, rocks, cobble or iron, for example, were historically used as ballast. So if you can imagine ballast stones filling the holds of cargo ships during the 18th and 19th centuries, and that ballast being needed to be manually removed from the vessel as it took on cargo in port in order to balance the weight, you can imagine piles of solid ballast material accumulated at ports around the globe. And offloaded ballast could then be used by other vessels while they were in port in turn. In the middle of the 19th century, though, iron replaced wood as the basic vessel building material, and that made the use of water for ballast possible. And so stone ballast was no longer needed for vessels, but was repurposed for construction material. So this photo here shows a granary and horse barn. This is located in the former Traverse City State Hospital that was constructed in the 1880s using stone ballast that came from schooners traveling across Lake Michigan. And this photo here on the right shows another example of a street on the north edge of Savannah, Georgia that was constructed with ballast stones. Okay, so now you know a little bit about ballast water, what it is and why it's important. I want to talk a little bit more about how using ballast water has had unforeseen and unintended consequences globally. There are many reasons why aquatic non-native species may be harmful. Non-native species disrupt the ecosystem and its balance. They have no natural predators, and so once they're established, they can outcompete native species and alter the ecosystem. This can ultimately lead in loss of biodiversity or the number of species that are in a habitat naturally. They really wreak havoc on regional economies as well in their impacts to fisheries, recreation, tourism, and of course the efforts to mitigate them. There are several ways that aquatic non-native species can be introduced. These include aquarium release, bait release, and also even intentional stocking. My presentation today is focused on the shipping vector. And within the shipping vector, there's a couple of ways that aquatic invasive species can be introduced. I'm going to focus today on ballast water, but there is also the potential for hull fouling to occur. This is something that is more prevalent in ocean-going vessels where they have organisms like barnacles and other organisms that are able to easily attach to the side of a ship and be carried around with the ship. All right, so I want to just orient everybody to some definitions that I'm going to be using in my presentation today. The first is, what does it mean if a species has been introduced? So scientists use this term to mean that they have observed a species that has had no recent evolutionary history in the area of observation. When we say that a species is established, this means that the species has likely formed a persistent and reproducing population. So typically, this species is found in two separate locations within a region, or perhaps it's found in two separate collections in 2 different years. Um, Once a species has become established, it is extremely difficult and expensive to control. It's it, when what m- and then it what makes an aquatic non-native species invasive? So when we say a species is invasive, it means that that species causes measurable negative ecological and or socioeconomic impacts. Within the Great Lakes, about 30% of the documented 190 non-native aquatic species are invasive. And really, I want to emphasize that we don't know ahead of time which species will become invasive. So really, prevention is the key with introduction of aquatic invasive species. All right, so how does this all work in the scheme of ballast water and its role as a vector in introduction of aquatic invasive species? So vessels, one way and one most typical way that vessels use ballast water is in port during cargo operations. So vessels will unload cargo at port. Doing that, they also will take on ballast water to keep that buoyancy, to eliminate that buoyancy and keep those conditions safe on board the vessel. They're taking in the organisms in their ballast water tank that are at the source port where they are discharging their cargo. And then they're going to voyage to their destination port with the cargo hold empty and the ballast tanks full. Once at the destination port, they're going to be loading cargo and they're going to be discharging ballast, again, to keep the balance safe. And when they do that, they're also discharging organisms that were entrained in the ballast tank during that time. And so then you see here an example of the cargo hold being full of cargo and ballast tanks empty. But importantly, vessels actually retain about 5 to 10% of the water in their ballast tanks. They also accumulate sediment in their ballast tanks over time. And so therefore, even empty ballast tanks contain residual water and sediment. And this is an important point that I'm going to be coming back to later on in my presentation. So what is in ballast water? The answer is very, very small things. A normal eye with regular vision and unaided by any kind of tool like a microscope can see objects as small as about zero point 0.1 millimeters or 100 micrometers. So that's this line here. That's about the width of a human hair. So when I say that ballast water has had unforeseen consequences, I mean that quite literally because organisms in ballast water are typically falling within this red box and literally cannot be seen by a human eye unaided by any tools. So it did take a while for scientists to become aware of the importance of this vector. All right, so I want to zoom in a little bit. This was the area in that red box on my previous slide. Zooming in on these microorganisms, the researchers that study ballast water are really looking at the effectiveness of different management strategies for ballast water within the scope of several categories of organisms. And those organisms are pathogens and plankton. And pathogens can be things that are harmful to humans, like E. coli, which is actually pictured here. And these pathogens are very, very small. As you can see, they fall into the range of maybe 1 to 10 microns. And they also include things that could be harmful to fish, like viral hemorrhagic septicemia. In the Great Lakes, we also are looking at phytoplankton. Here's an example here of a diatom. And these form the basis of the food web. So they're kind of the things that everything else eats. And in the Great Lakes, a lot of our phytoplankton can be 10 microns or less. They can also form very long chains and stick together and be quite large, able to be seen in some cases with the human eye, but mostly microscopic. And then thirdly is zooplankton, which feed on phytoplankton. And these are generally a little bit larger, but still very small, very tiny microscopic organisms, generally greater than 50 microns in size, but can range up to 100 microns in length. So you can see here kind of the things that we're talking about and just how small they are in comparison on this chart. Between 1959 and 2006, there were 1.7 aquatic non-native species per year introduced to the Great Lakes. That means that the Great Lakes is the highest recorded invasion rate of any freshwater ecosystem. And ballast water release from transoceanic shipping is deemed responsible for about 65% of the invasions in the basin since the modern St. Lawrence Seaway opened in 1959. I highlighted the word transoceanic in my previous slide because there are some important differences between ocean-going vessels or salties and Great Lakes vessels or lakers. Although there are some Lakers that were built in 1952 that are still plying the Great Lakes, many of the vessels that you see when you're in a Great Lakes port are quite large, commonly more than 800 feet in length, and some 1,000 feet or more. And these types of vessels were built largely around the 1980s. In contrast, the maximum size of a salty that is coming into the Great Lakes St. Lawrence Seaway is going to be 740 feet. And so that is important in this scheme of things, because the locks at the Welland Canal here allow for vessels no more than 740 feet long and 78 feet wide to traverse through. This means that most Laker vessels are going to be confined to Lake Superior, Michigan, Huron, and Erie. So importantly, ocean-going vessels are the vessels that are introducing aquatic non-native species. They're the primary source. And Laker vessels are going to be the ones that are spreading them, or the secondary source. With respect to secondary spread of aquatic invasive species, U.S. to U.S. Laker trade routes influence which Great Lakes ports receive ballast water. This is because Great Lakes ports are largely either cargo loading or cargo offloading ports. If they're a cargo loading port, they're of course going to be deballasting. And if they're a cargo loading port, they're going to be deballasting. And if they're a cargo offloading port, they're going to be ballasting. So what this means is that in general, U.S. Lake Superior ports, like the Port of Duluth Superior or the Port of Two Harbors, are going to be receiving a lot more ballast water, as is the case with iron ore trade routes, as shown on the screen. And so one of the predictors of aquatic invasive species establishment in a port is the number of species that get discharged in that port. And so that means that some of the ports that are largely ballast water discharge ports are going to be more of a hotspot for invasion because of the risk with the amount of ballast water being discharged in those ports. All right, so I've told you all a little bit about what ballast water is and why it's important, its role as a vector for aquatic invasive species introduction. I want to talk a little bit, just introduce you all to ballast water management policy and research and the impact that those two things have had on reducing the establishment of aquatic non-native species globally, but also focusing on the Great Lakes St. Lawrence Seaway. Okay, so I mentioned before that it took scientists a while to realize the extent to which the Great Lakes were being invaded and why. But by the late 1980s, early 1990s, there was mounting scientific evidence as to the increasing number of introductions since the opening of the modern St. Lawrence Seaway in 1959. So with that mounting evidence, in 1989, Canada requested that vessels coming into the Great Lakes St. Lawrence Seaway conduct mid-ocean exchange of ballast water. And that was a voluntary practice. They weren't required to do that. And then in 1993, the United States followed suit by requiring, under the authority of the Non-Indigenous Aquatic Nuisance Prevention and Control Act, that ballast water exchange be performed for all vessels that are coming into the Great Lakes St. Lawrence Seaway. So this then became a requirement. What I mean by ballast water exchange is really a pumping out of ballast water that was taken on at the port at the source port. And then mid-ocean before a vessel arrives at that port, it's going to be pumping out that ballast water and exchanging it with open ocean water. This does a couple of things. If the source port was a freshwater port, that salt water can act as a lethal substance to some organisms contained in the ballast tank. But also, when we think about the mid-ocean, we think about a less productive system, so a system that doesn't have very many organisms in it. And so you're exchanging organisms from a source port that has could have a lot of organisms with organisms that are much fewer in the open ocean. So looking at the research having to do with the implementation of this regulation, if we're looking at the period of time before the regulation, so 1981 to 1993, there were 16 species introduced to the Great Lakes Basin during those years that can be attributed exclusively to ballast water release. All right, so then we have this ballast water exchange regulation that is required by the United States for fully ballasted vessels. So let's look at the data from after that regulation was put into place. In 1994 to 2006, there were 15 species introduced to the Great Lakes Basin attributed exclusively to ballast water release. So 16 to 15 is not much of a difference. And why might that be? Well, the answer actually lies in the fact that many of the vessels, 75 to 90%, 95% of the vessels coming into the St. Lawrence Seaway had declared no ballast on board. So they looked like this. Their cargo holds were full, but they've declared that they have no ballast on board. And those rules that were set in place didn't apply to them. They only applied to fully ballasted vessels. Um, so remember what I had said earlier about residual water and sediment being still present in empty ballast tanks. Well, scientists found that residual water and ballast sediments actually contained many organisms like diatoms, like organisms that really love to live in the sediment. They sort of live in that interface between the sediment and water, and life stages of organisms like resting eggs that come from zooplankton. These organisms are tolerant, they're robust organisms. In some cases, they can tolerate a range of salinities. And so in 2005, scientists by publication showed that these no-bob vessels actually are a greater risk because they carry organisms. They make up such a great proportion of the or of the vessels coming into the Great Lakes St. Lawrence Seaway, and they do not undergo ballast water exchange. So let's go back, looking at our timeline. And importantly, after scientists became aware and policymakers became aware of this issue in 2006 to 2008, Canada and the United States mandated something called open ocean flushing. And this was mandated for vessels that had declared no ballast on board. And what this really is when a vessel is in mid-ocean and they have no ballast on board, what they're going to be doing is they're going to be filling up their ballast tanks with salt water. Everything in that ballast tank, that residual sediment and those organisms are going to be mixed up during that process. And then they're going to be pumping out that ballast water that they had just taken on in mid-ocean. Similar concept to what I described for ballast water exchange. This is really trying to get rid of those organisms that are residual in the sediment and in the remaining water. And for those that aren't flushed out, if they're freshwater organisms or have a low salinity tolerance, this salt water is going to be lethal to them. Okay, so let's go back and look at the data. We have, in the period before any regulations, 16 species being introduced. Now we have mandated ballast water exchange for fully ballasted vessels. We have 15 species introduced. And scientists have now found that we need to mandate saltwater flushing. And so in the time period between 2006 and 2008, we're looking at the years following that regulation coming into place. And there were only 2 species introduced in the years between 2007 and 2019 to the Great Lakes Basin, attributed exclusively to ballast water release. That is a huge and marked difference that scientists have correlated to this regulation. So it is an example of policy impacting the resource that we have in the Great Lakes and St. Lawrence Seaway Basin. What this is doing is really reducing the risk of establishment. So you're not making the risk zero because you're still releasing some organisms after the ballast water exchange and saltwater flushing, but you're eliminating some of the organisms that would otherwise have been introduced. And in that way, you're reducing the risk of establishment by reducing the number of organisms released. So, what is the rest of the world doing during this time? I want to tell you a little bit about this because this is, of course, a global problem, not just a problem in the Great Lakes St. Lawrence Seaway. So, going back in time now to 2004, the International Maritime Organization adopted something called the International Convention for the Control and Management of Ships' Ballast Water. This is called the IMO Convention. And in 2010, Canada ratified the IMO Convention, which required ballast water exchange, which is something they were already asking vessels to do coming into the Great Lakes, but also had a standard that required something called ballast water treatment. So actually treating the ballast water to remove organisms. In 2017, enough countries had signed on to the IMO convention, joining Canada and others, that this convention was entered into force globally. And now, as of 2022, the IMO convention has 92 countries as signatories, representing about 91% of the world's gross tonnage. So that's what's happening globally. And all this means that most ocean-going vessels, including Canadian vessels, should have ballast water management systems installed on them by 2024. And I'll talk a little bit more about that coming up. This map shows the countries that have signed on to the IMO convention. So globally, these are the countries that in green that would be signatories to that IMO convention and would be following that. You can see that the United States is not one of them. And also that's important because, of course, the Great Lakes St. Lawrence Seaway is a binational seaway. So let's just take a look here. What is the U.S. doing during this time that Canada is ratifying the IMO convention and the rest of the world is kind of signing on to this policy? Well, in 2012, the United States Coast Guard required all ocean-going vessels to meet a ballast water discharge standard, very similar to this D2 standard that I told you about. And the US EPA did something similar regulations in 2013. So what is this ballast water standard that I've told you about that now globally through the IMO convention and within the US, vessels are required to follow? I'm going to go back to this chart that I showed you showing sizes and sizes of organisms that we're generally concerned with when we talk about ballast water. The ballast water standard is really looking at these types of organisms, these really small things, and it's dictating how many of those organisms can be released because remember, the number of organisms being discharged by ballast water is really correlated to the risk of establishment of organisms at a port. So when we're looking at zooplankton, those sort of larger organisms in kind of in this category here, size category, we're looking at a standard that dictates that a vessel release less than 10 living organisms per cubic meter of water. Moving down in size to phytoplankton, the standard is dictating that less than 10 living cells of phytoplankton get discharged per milliliter of ballast water. And then there's some standards for some pathogens that are of concern that sort of are a proxy for all the other pathogens that could be in ballast water. And so scientists are looking at E. coli, enterococci, and Vibrio cholera. And the discharge standard dictates a certain concentration or below that those are of discharge of those types of organisms, of those pathogens. The only way that this is possible with the technology that we have today, because it's not possible with ballast water exchange, it's not possible with saltwater flushing to get this low of concentration of organisms, is through a ballast water management system or a ballast water treatment technology. So this is a process that I'll walk through with you all where a ship is going to be taking on ballast water. It's going to be pumping it on board, and the ballast water management system is going to be going through a series of steps to reduce the number of organisms taken on board. The first step is usually a mechanical process like filtration or hydrocyclonic separation, and this is going to remove larger organisms, usually zooplankton, but also sediment particles that the ship takes on. Those particles that are removed are going to be backwashed overboard at the source port where the cargo operations are taking place. And then the water that has been filtered is going to be taken through a chemical or physical disinfection process. And that could be things like ultraviolet irradiation, it could be chlorination, it could be deoxygenation. There are a lot of different commercially available ballast water management systems on the market that treat ballast water in a myriad of ways. So this is kind of a general example of what might occur. And then the last step, if it's needed, in some cases, in the case of a chemical treatment, sometimes neutralization of that treatment is needed before the ballast water can be discharged overboard. So that would be the third step in that case. And again, this is getting at a reduction of risk. It's not zero risk, but we're now kind of doing a job of eliminating many of the organisms that would normally be discharged during loading cargo operations. So within those regulations passed in the US in 2012 and 2013, Great Lakes vessels, Lakers, built prior to 2009 are exempt from meeting the discharge standard. And there are a couple of reasons for this that I'll explain. The first has to do with Great Lakes water quality. The fact that we have basically no salinity within the Great Lakes. A lot of the ballast water treatment technologies, the systems that have been developed for ocean-going vessels who take on ballast water that's salt water. And that's important because a lot of the ballast water treatment technologies that are available on the market actually only function in a saltwater environment. Our water is actually here very, very low temperature, much of the year close to freezing, especially in Lake Superior. A lot of the systems that have been approved and are commercially available aren't able to function at temperatures quite this low. And then the last thing is the high turbidity. A lot of our ports in the Great Lakes are close to river mouths. They have a lot of suspended sediments in the water, and this can be really challenging, especially for that first filtration step that I talked about. So these are reasons, water quality reasons, why this exemption has taken place. And then the second big reason is unique operations of Laker vessels. Laker vessels have really high flow rates of ballast water, and a lot of the commercially available systems on the market are made for container vessels that do not have this high of a ballast flow rate. And so a lot of what's available on the market wouldn't work for a Laker vessel because the flow rate of the ballast water is too high. Um, Likewise, very high volumes of ballast water goes into and out of Great Lakes vessels during cargo operations, and these treatment technologies just aren't equipped, many of them, to treat these large ballast volumes. And we also have really short voyage times from port to port. And that's important because some of these technologies are relying on a treatment time. So let's say, for example, a chlorination system, it's going to need perhaps a certain number of days in order to treat effectively um, the organisms that are contained in the ballast water. And that normally wouldn't be a problem for an ocean going vessel, but it is impossible for a Great Lakes vessel. So a remaining research question is, are there treatment systems on the market that are commercially available right now to treat Great Lakes ballast water and meet that discharge standard? So there are scientists that are investigating this, and this is being done through a program called the Great Lakes and Lake Champlain Invasive Species Program. This program was written into the U.S. Coast Guard Reauthorization Act of 2018, and this this reauthorization act required that the U.S. Environmental Protection Agency establish national standards which is really important because prior to this, states were able to establish their own ballast water standards. And so there was a mismatch of standards throughout the Great Lakes and St. Lawrence Seaway, as well as on the east and west coast, of states requiring different ballast water standards. So this, importantly, Reauthorization Act established national standards. The Coast Guard is going to enforce these standards, but importantly for our conversation today, this requires the U.S. Great Lakes National Program Office, the EPA, to establish this Great Lakes and Lake Champlain Invasive Species Program. And this is being implemented right now by the U.S. Maritime Administration and the Great Waters Research Collaborative, which is located at the University of Wisconsin-Superior. And these scientists right now are working to research and pilot ballast water management systems for Laker vessels. All right, so I don't want to speculate too much, but I did want to talk a little bit about what the future holds for Laker ballast water management, and some research that is very recent coming out of this. So I've talked about globally in the United States, the regulations that have taken place because of the data that scientists have collected about the risks of aquatic invasive species from the ballast water vector. Um, what we've have recently is because ballast water management systems have been put in place, um, scientists have been able to sample ballast water of ships that have operational ballast water management systems. They're actively treating their ballast water. And so I'm presenting some information from one of those studies that was done. So this is operational ships which have ballast water management systems installed. Going back to the standard that I showed you earlier, when we're looking at phytoplankton and the samples that were being discharged after treatment, we found that none of the samples exceeded the discharge standard in this particular study that was done. And then in a subsequent study, looking just at zooplankton, at those larger organisms, we found that 48% of samples exceeded the discharge standard. So there was some issues with some of the ballast water management systems on some voyages not treating to this less than 10 living organisms per cubic meter. In some cases, that was exceeded. Importantly, a conclusion in this particular publication is that the frequency of high risk introductions, so ships that may be introducing a lot of organisms, was reduced using a ballast water management system, even though the targeted discharge concentrations were often exceeded. And that is because even in a non-functioning or less than ideal functioning ballast water management system scenario, there are less organisms being discharged than would otherwise be the case. And so again, the whole goal here is to reduce the number of organisms that are being introduced. So yeah, we're reducing these organisms being discharged at the ballast water port. One thing that scientists are considering for potential treatment options for Great Lakes vessels that could be implemented in the future is treatment technologies that are land-based. So there are certain routes that certain ships may take. Let's just say, for example, they're going in between consistently Escanaba and Indiana Harbor. There's a ship going consistently in between these two ports. It may be possible for that vessel to have land-based treatment. So there's a ballast water management system that isn't installed on the vessel, but it's installed at the port. And because that vessel is going in between those two ports on a dedicated route, that option may be something that would work really well and would avoid issues of having the cost of installing a ballast water management system and retrofitting a vessel for that technology to be put in place. So that is something that scientists are looking at through that Great Lakes and Lake Champlain Invasive Species Program. Now I'm projecting way out into the future to another potential future scenario, and this is showing a ballast-free ballast-free bulk cargo carrier. So ballast-free ships is something that was thought up in the early 2000s and requires that a new vessel be built because this is a completely new type of vessel that doesn't exist. It's very conceptual at this point in time, but instead of ballast tanks, we have these trunks, and we eliminate the need for taking on ballast water by having constant flow of water through a network of trunks running from bow to stern below the water line. So no longer do we need to take on ballast water and discharge ballast water, eliminating the risk entirely of aquatic invasive species introduction. There's some work that has been done out of the University of Michigan's Marine Hydrodynamic Laboratory to help fine-tune this design for the Great Lakes and vessels that are small enough to kind of go in and out of the Great Lakes St. Lawrence Seaway system. But again, this is a very conceptual idea at this point in time. There aren't any vessels that actually exist that are of ballast-free design, but something that scientists are very much thinking about for the future. Going back to regulations, I mentioned that the 2018 U.S. Coast Guard Reauthorization Act required these national standards. National discharge standards had to be written. So looking ahead to the future, in October 2020, the US EPA had drafted these national discharge standards. As of today, no final standards of performance have been released. So that is something on the horizon, is that we will see at some point in the future these national standards of performance being put into place and finalized, and see what may or may not occur with lake or ballast water management at that time. In June 2021, with the Canadian regulations, there was new ballast water regulations issued. These regulations apply to vessels that are plying in Canadian Great Lakes waters, and they're required by September 2024 to meet a discharge standard, that discharge standard that I talked to you all about earlier. Importantly, though, this only applies to vessels that are newly built. So vessels that are built before 2009, which is almost all of the vessels on the Great Lakes, the U.S. Lakers, except for one, do not have to follow this discharge standard until September 2030. So it gives scientists a little bit more time to answer that question of, is there a treatment technology available on the market that can effectively treat lake or vessel ballast water. So this allows a little bit more time for that to for that question to be answered. Okay, so I hope that today I was able to show you a little bit about why ballast is critical to maintain the stability of a vessel and the safety of the crew on board. That using water as ballast has had some unforeseen and unintended consequences globally, as well as in the Great Lakes and St. Lawrence Seaway system, and that science-based ballast water management and data-based policy have reduced the risk of introduction of aquatic non-invasive species from ballast water. So this is my contact information. If anyone should have a question after the program has concluded, there will be a Q&A session. I'm going to stop sharing my screen and let Sarah make a couple of announcements, and then we can do some Q&A. Thanks, everyone.
Thanks, Kelsey. That was really interesting. That's great. I'm going to share my screen again, and let's see. And just provide a couple of updates for you. I know this isn't displaying as we necessarily want it, but information is still there. Just wanted to update everyone. We started doing these visitor center status updates when we were still closed, but since we do change them seasonally, we're just keeping the public updated on our information and everything. So in Duluth, our visitor center is currently open Thursday through Monday from 10 a.m. until 4:30 p.m. We do offer cell phone tours outdoors and have virtual online tours of the visitor center. And we have an online gift shop. The Sulaks Visitor Center in Sault Ste. Marie, Michigan is closed for the season until Mother's Day. I believe their park is still open, and they do have online exhibits and information sheets. And their boat schedule is not running anymore, but that's their status. And then we have hopefully our next program, which will be on January 3rd, is we're hoping to get a crew member from the Coast Guard Cutter Spar in Duluth to speak to us about that vessel and icebreaking missions. So that hasn't been confirmed yet, but we will provide a link once it is confirmed. And then finally, I just have some information about our respective organizations and links to our Facebook pages. And we mentioned before that the Detroit District Army Corps of Engineers has their own YouTube channel where these programs have been recorded, and there's a playlist in there for you. So I believe we'll be getting that link in the chat for you too. So I'll just leave this up, and then we can start asking or start addressing some of the questions. Kelsey, did you want me to read them to you, or do you just want to go through them?
Oh, I can do it, Sarah.
Okay.
I didn't see any questions earlier, like while I was presenting. So I'm going to start with the first one that I see in the chat, which is what ballast system does the new ship, the Mark W. Barker, have? And the new ship does not have a ballast water management system installed on it. So I mentioned that there is an exemption for vessels that were built prior to 2009, and this is a brand new build. So they sort of have an exemption to the exemption. And that is because of the reasons that I discussed earlier, the challenges associated with ballast water treatment for Great Lakes vessels, those are very much still existing. So science hasn't really tackled that problem or answered that question of whether there are existing ballast water management systems on the market or ones that are to be developed or are being developed now that can treat ballast water on Laker vessels. So right now, there is space on the vessel for a future system once one is found that will be effective to be installed on that vessel. So that's where that stands. There's a question, is this how I read your map? Only U.S. ports on the Great Lakes with discharge, intake, and outtake, no Canadian ports. So I think that you're referring to the sort of the trade route map that I had, and that was looking at just U.S. to U.S. Traffic, and it wasn't looking at Canadian ports. But you know, the same sort of concept applies to Canadian ports as well. They're within the Great Lakes, really the ports are kind of specialized in either, you know, this is a cargo loading or a cargo unloading port. And that's true in both Canada and the US. So even though the map wasn't really showing that because it was that particular research study was just looking at US ports, the concept applies to the binational waterway because largely our Great Lakes ports are very specialized in that way, in the commodities that they trade and where they're loading them and offloading them. And so that means that there are some ports in the US and in Canada that receive more ballast water discharge than others because of the trade routes. Yeah, so what are some of the worst introduced alien species in the Great Lakes attributed to ballast water? Um, as you know, as I kind of talked about, that once something becomes invasive, it really is going to have a socioeconomic and an ecological consequence attributed to it, a measurable consequence. But when we think about really when a lot of the problem became known and a lot of the regulatory aspects started occurring, was around the time that zebra mussels were introduced or that their establishment became known to scientists. And so I think that the driver for a lot of the policy were things like zebra mussels. And so, you know, I don't want to point out that as the absolute worst, but I think that that was a driver of a lot of the subsequent regulations that occurred. Um, and then, do the new rules include the middle states, not near an ocean or the Great Lakes? So Mississippi River, it would be an example. I think is what you're referring to. And to my knowledge, the regulations are applying to vessels coming into the Great Lakes, into great U.S. waters. And so if a vessel is coming into the Mississippi River from outside, so it's an ocean going vessel, then the ballast water rules apply to that vessel. That's all the questions that I see at the moment, but maybe we'll give it one more minute and see if anybody else has anything that they've thought of.
Yeah, we can wait a couple minutes. Kelsey, do you want to talk about how you became in how you entered into this industry and what your background is a little bit?
Yeah, sure. Yeah. And yeah, so the question, yeah, and also, do I go on board to test ballast water? Okay, so my sort of trajectory is that I am formally trained as a toxicologist. And I actually got my degree at Iowa State University. So I was looking at crops and proteins that were in crops that had been genetically engineered to express insecticidal traits. So probably couldn't imagine a further line of study between that and ballast water, but that's where I started. And toxicology concepts are, you know, they transfer to a lot of different ecosystems. And so I'm actually from the Duluth Superior region, and I had the opportunity to come back and work at the Lake Superior Research Institute at the University of Wisconsin Superior. And that is where sort of my path started on ballast water, because they had been really actively involved in ballast water management research from very early on, very early days. And so at that time, we were testing ballast water treatment technologies at various stages of development. Many of them were prototypes that weren't available on the market. And we were, as time went on, we were able to test technologies that were more commercially developed, up to the point where they were actually being tested for regulatory purposes. And we were going on board ships in the Great Lakes to test these, but we were also going on board ships in far-flung locations like Algeciras, Spain, to test ballast water management systems that were being tested for regulatory purposes, trying to pass the test of whether or not they could be commercially marketed. So yeah, so I have spent a lot of time in engine rooms on board vessels, Great Lakes vessels, as well as container vessels globally, sampling ballast water. It was something that I really enjoyed. And now I don't so much go on vessels anymore to sample ballast water, but now I am able to sort of take what I've learned and communicate a lot of the science that others are doing to you all and others, so that they can apply that in their work. So that's Hopefully that answers your question, Sarah.
Yes, it does. Thank you.
And then, okay, are the new rules set up to include the Dakotas or states similar? And yeah, so the new rules are going to be covering um, covering port locations, not so much small waterways, but they're going to be covering U.S. waters where there are commercial vessels that are going to be loading and offloading cargo. And so that includes East and West coasts. It includes Great Lakes St. Lawrence Seaway. It's going to include Mississippi River. So navigable waterways is the word that I'm searching for. Um, like the Ohio River. I'm not sure how much commercial vessel traffic is going on the commercial on the Ohio River, but if that is a navigable waterway and it's lots of coal barges, then yes, that would apply.
All right. Well, I don't see any questions. We could wait another minute or two and just see if we get any. Otherwise, I just want to thank you again, Kelsey, for your time and for sharing this information to us. We get a lot of questions at our visitor center about invasive species, and this is really good explanation and how ships how they play a role in moving invasive species around the Great Lakes. So really interesting.
Yeah, thank you. I do see one more question about the new the ballast-free ship that I mentioned. That's a conceptual future state that people are looking into now. And so the question is for the new ballast tank design you mentioned, I assume the flow-through design would be used when the ship is in ballast. How does it work when the ship is not in ballast? And actually, the whole concept of having to ballast with this ship design is null and void. So there is no longer any ballast tanks with this design. It's a flow through system where local water is flowing through at the time when the vessel is underway, and it eliminates the need for ballast altogether. So there is no more ballast with this particular design. And like I said, this is still a very much conceptual thing, but something that people are really looking into for the future. I think there are some cost savings too in certain ship designs for this particular ballast-free concept. Okay, did the lack of regulation for U.S. ships help speed the spread of zebra mussels? It's hard to go back and say what could have or would have occurred. So it's hard to project backwards or forwards really, but so what I can say is that because of the science and the data showing that there was an increasing number of invasions happening in the Great Lakes St. Lawrence Seaway Basin, that data really spurred policy, and that now we know that that policy did really make a difference at that time. And so it is possible that, during the before that time, before the science kind of got caught up, and then policymakers, likewise made regulations to combat what science was showing us, that there were, organisms that were being introduced. Some of them became established and some of them became invasive. As I showed, about 30% of the 190 became invasive. And what's the most harmful invasive? I don't know if, there's not, to my knowledge, been a study that's kind of been done to say, to actually put measurable um, dollar figures and socioeconomic impacts comparing invasives in the Great Lakes. And I think that would be an interesting study, but to my knowledge, that hasn't been done yet. But and I mentioned there are a lot of other vectors in addition to the shipping vector. So, things like sea lamprey have been, very harmful. That's an invasive that came through the canal pathway, not necessarily through shipping. So regardless of the vector, prevention is really the key in order to make sure that those invasions don't occur in the first place. And I think that might be the end of the questions, potentially.
Did you see the one above that? It was regarding the new ballast system. How does this deal with the fact that the ship weighs a lot less when empty
Oh,
than when loaded or during loading?
yeah, yeah. And I wish that I had a more thorough knowledge of the ballast-free design. And so unfortunately I can't really speak to, the engineering and the mechanics of how this works. But I do know that there are people, University of Michigan researchers and others who are working on figuring out how that would work and starting with very small prototypes. And I think there are companies globally that are getting a little bit closer to making this happen. And for us within the Great Lakes, we have bulk cargo carriers. It's a different kind of ship than, the big container vessels, and ballasting systems are different. So it may be that the container vessel ballast free ship might be the place where globally things start to happen. But it is probably a little bit more difficult mechanically for bulk cargo carriers to make this concept work, but there are people thinking about that and working on it.
And there was just another question about is there a solid idea to stop Asian carp from harming the lakes?
Yeah, so there is the Brandon Road Lock and Dam project that is taking place. That is the solid idea that scientists have to stop Asian carp from entering the Great Lakes. So we know that they're close, and that is the area that all of the funding and efforts are being put into to stop them from getting past that area and into Lake Michigan. And then there are lots of efforts, monitoring efforts being done to make sure that, that in fact there aren't any Asian carp that have been introduced to the Great Lakes St. Lawrence Seaway. So that's being done, as well as the efforts at Brandon Road Lock and Dam to stop the Asian carp from being able to enter.
Awesome. Well, I think we're getting to the end of it. There's a survey link if anyone would like to take a few minutes to fill that out. We use it to learn how our programs go and if we can make any improvements or anything to them. Please let us know. Otherwise, thank you everyone for participating today. Hopefully we'll see you on January 3rd for our next program, and just have a good holiday and take care. Thanks everyone. Have a good day.
Thanks, Sarah.
Thanks, Kelsey. Appreciate it.
Bye.
Bye.